so this is the final panel, data management and trust. Chris Etzel, Cambridge University. Please take it away.
Thank you very much. I guess the first order of business for the last panel of the day is for the panel to be introduced, and I think it'd be more effective if they introduce themselves. So if we start from the far end with Andy.
Yeah, sure. So I'm Andy Yates. I'm one of the team leads at EMBL EBI. I'm also PI of the Ensemble project and PI of the DCITE project, which is a database for rare variants in disease.
Hi, I'm Loïc Lanong. I'm a postdoc at the University of Cambridge, working on cardiovascular research, but also thinking about the carbon footprint of HPC and computing.
Thank you. Hello, I'm Jaz Kalyan. I'm a senior computational scientist at SCFC, and I'm mainly working on the PSDI project that I presented earlier, looking at making data more fair in the biomolecular simulation community.
Cool, and the title of this panel is Data Management and Trust, and that's quite a broad field, which is good. That gives opportunity for the audience to ask questions about pretty much anything, as long as it covers either data management or trust. But I'll use my privilege as the chair to go first and ask a question about data availability. So there's a statement that quite often you see at the bottom of a paper that says data available upon reasonable request. And about 3 years ago, somebody tried that. They found, I can't remember which journal, which field, I think it might have been biology. They found 1,000-ish papers and emailed all the authors who said that the data was available and said, so can we have it then? And they got 40%, which was okay, but so what are the challenges with providing data, research data?
I'll start, I think. I think for the biosim community, it's because our projects are so varied, we don't know how to store the data to make that available. So we're just thinking about analysing the trajectories and publishing those results, but then how do you store away your data in a format that allows people to reproduce it? I think that's quite difficult, even for themselves, to do, to reproduce their own data. And so if there was some sort of framework that, or some guidelines of how you should be packaging your data to make that more easily shareable, like provenance tools, that might be a good idea.
Yeah, sure. So there's an aspect of ensuring there's an incentive for researchers to deposit, and that deposition could be into larger archives like an EBI or into resources like Zenodo. There is a certain inflection point though where I think that it's great if people do deposit into something like Zenodo, but there becomes a point where a community has to coalesce and to agree on standards, on structuring, on consistent metadata, and then I think it's that point when these archives start to appear. So actually then it becomes, and hopefully as part of that realization, that process, then it becomes easier to actually submit. But I do think that there is still an onus on the journals, and unfortunately on reviewers, to ensure that when journals say you have to submit into a particular archive or your data has to be available at this particular point in time, that it truly is as well. So there is an onus definitely on the researcher, and they have to make sure it's actually to their benefit to submit, but also the journals need to step up as well and make sure that this is actually being followed if it's part of the guidelines.
Yeah, I mean, that covers it.
So that's interesting. It's a very similar answer when the same question is asked about code. It's about incentives and journals and reviewers having an obligation to check the code availability statement. Does anybody have a question about data management or trust? Yes, in the back.
Thank you very much. I was just wondering, so why is it difficult for researchers at the moment to reproduce their own paper? Could you please provide more information for those of us who are not computer scientists who are regularly working with data?
I think it's difficult to reproduce biosim data, so because we have so many different steps involved in actually trying to get the simulation to work. And it's not always that the steps that you take work the first time, so it can be quite messy for trying to produce a simulation. And by the time you've got it working, you might not even remember how you actually got it working in the first place, because there were so many steps involved and you're just glad that it actually is working. So I think that's one of the reasons why I think it's quite hard to reproduce and share the data that we produce in our community.
Just on the data aspect, one other thing is obviously thinking about carbon footprint. One of the big things is thinking about deleting data. And actually I think that having proper processes to do the data management, and we always go to the point of having enough backup, but usually most people stop there. And actually there's a step after that, which is deleting the data you don't need to keep. And I mean, there are so many examples where there are terabytes of data sitting there, no one knows what it is, no one's ever going to be using them, but no one dares deleting them. And that makes it harder to reproduce, because then you've got a bulk of data, you know one of these files is the right one, and the other ones are not, but you don't know which one. So actually, in some sense, sometimes deleting data can hopefully have good benefit for the environment, but can also help reproducibility and sharing data, because then even if you leave, if you just leave one file that then your PI can be sharing 10 years later or like 5 years later after you left, it still works.
So maybe following on from that, what are the gaps in the tools that we're using for data management in hardware, either hardware or software? Okay. What's missing that would make the job of data management easier?
So I think some of this does exist, but I always love to think of it's going to be someone else's problem to deal with data management, or at least that would be the best thing for me, for sure. Because the slicing through the data sets that you might be holding on to, it may not be obvious how to package and how to send that back to long-term storage, or eventually to actually remove altogether. And the mechanisms behind how you decide how important data is really obscure. There are projects going on at EBI at the moment where we're trying to rationalize down our FTP footprint, because it's becoming quite large and quite hard to deal with. And not impossible, I should say. But then we look towards access, and that just feels like a really poor proxy to something that actually what we're trying to look towards is the importance. So in what's missing, I think it's around that original metadata around the date, the entity or the data collection that's missing, because that is where the knowledge would lie about the importance or the requirements around how long something is retained for, or what is this in support of. Given the example earlier we had about 10-year retention around publication, surely that's important to have on a data set and to annotate and say, yeah, you know, this is in support of this publication. In fact, it's not just in support of a publication. This is the DOI that it supports. So when you go past that point, off it can go. So I think the tooling, we seem to be missing something in the tooling around how we annotate our data sets, which would give us better control over that promotion or demotion and eventual deletion. Otherwise, I think we're just in this other world where we're just looking at how often something gets accessed, and then we're sending it up and down on blocks, and then we're looking for vendor-specific solutions around that.
Mark's got a question. Oh, actually, sorry, finish off on the tools, the missing tools.
Well, and maybe I'll use the audience for that, but I've come across this situation where we had at some point, let's say 200 terabytes of data and hitting the maximum, and we're like, we shouldn't have 200 terabytes of data, we don't have that much data. And so we went to some people managing the storage, and our question was, what is this data? Can you tell us who owns what? And the answer was, we can't. So if I can ask, you know, who, is it a common situation, or like, who here thinks they can access, people in charge of HPC maybe think they can kind of label the big chunk of data to owners, or?
So show of hands for can. And show of, it's about, well,
And show-
20% of the room, show of hands for can't.
Okay, so not that
Not many
common.
people admitting, so the majority can.
So I think
Can I add a caveat? Yes,
Yeah.
most of them would have left.
exactly. I think in my case I can identify who the data belongs to, but then what we can't do and what they probably can't do is say which bits they can safely delete.
Yeah, no.
Or more importantly, can't find the time to safely delete that.
No, that's fair. But I think in some situation, apparently, even the first step of knowing who it belongs to is a bit tricky, I think, in some system. And because we're like, if people have left, then
Yeah.
the PI can take the decision of deleting it. But that might be a tool that's missing in some situation.
There's a distinction between who owns the data and who puts it on the system.
Yeah.
And in some cases that can be very, very different. So the PI can be responsible, have ownership of the data. They never touched the system in the first place. It was owned by a user, the user had to write it. So the question of who is responsible for it might be a more difficult one than
Yeah.
who owns it. Unix term ownership.
Yeah, that's a good point. Thanks.
Jez, have you got a missing tool?
Not a tool, but maybe culture. So I think in structural biology, you have somewhere to deposit your data and add metadata that you want to, but in a lot of other fields, you don't have that. So you're just holding onto your data and you don't know what to do with it because there's nowhere to put it.
Mark, do you have a question?
Yes, I was wondering, should we be linking carbon footprints of research to reuse of data? Because if I put in the work, I mean, it won't work in every field or for every project, but if I put in the effort to find some data that you've generated, and I can then use that rather than generating it myself, that should be incentivized, because that'll mean I don't need to generate it and the carbon isn't being used, especially the simulation data is what I'm predominantly thinking of.
Yes, absolutely, we should. And actually, one of the Google papers I showed that was slightly attacking our results. The main point was, oh, the LLMs are enormous, but it doesn't matter because we train them once and then everyone uses them, which is true until the next team comes and try to train a new LLM to beat them all, and then it's kind of... But that's the point, and that's a fair point. And actually, in the slides, I had this example about EBI, about AlphaFold, and AlphaFold has a carbon footprint, and then there's ESMFold, which is one of the Facebook competitors. But that's really interesting how AlphaFold, the carbon footprint of AlphaFold doesn't matter so much because it got reused, you know, it was a few tons, but it got reused by everyone because it was teamed up with EBI. That was like a massive deal breaker. And so that's a completely fair way to say, okay, yes, we have a big impact, but of course it's worth it because look, we have like, I can't remember how many millions access we had put it in our papers. It was the API access was just ridiculous. So yes, I mean, the whole point is not to say, oh, let's not do science, but let's do science better. So yes, definitely should.
I guess that would work if there's some kind of quota associated in the background, and yeah, you do a download. I mean, even that download and then that subsequent storage on HPC has also a carbon footprint as well. But that is that pales into a significance about rerunning simulation, or even some of the algorithms we've got, which are not simulations. They are just complex order n squared algorithms, so they take a long time to compute, and you want to reuse that. And this reuse, I would actually say, helps with interchange of results as well. And because you're suddenly now basing on the same, you have results from perhaps two different groups that are based on the original same baseline data, which is far better than going back to an original raw data and then recomputing and then basing again on that. So you're just cutting out one more stage, and it's reducing that headache of submission and archival and everything else.
I forgot what I was going to say, but
So Mark's question, your question again?
Well, I have a kind of follow-up to it, while I think that trust then becomes even more important, because if I'm going to reuse your data, the more people that reuse it, the more, if that data is wrong or corrupted or whatever, that'll then percolate through. And I remember we had a discussion about this over the summer with some kind of biological data where the experimental data is old, but it's reused all the time and referred back to, but actually it's used out of context and things like that. So yeah, I don't know how we manage that. And it's the same as true for simulation data, taking it out of context.
But I guess if that wasn't open to begin with, you would have never known it was incorrect. So that's just, even though it was the incorrect data uploaded, at least you could have tracked it and said, okay, it was incorrect, and you would have never known that had it not been shared.
Yeah.
So that's something. I think also in terms of incentivizing reusing data, is to have something in grant applications where you can say, you know, this is the data, I'm going to get it from here, and I am going to save this much, you know, carbon energy because I am reusing it. So that surely should be an incentive to fund projects that are using less energy.
I mean, the other place to put this is in data management plans, which, and eventually I know the Global Biodata Coalition has a call out at the moment for comments, and one of those is around how data management could happen. And part of that is also potentially machine actionable data management plans as well. So this might actually be another step towards not only standardizing data management, but also making researchers think about data lifecycle as well as inputs and outputs, and also how does that then feed into systems to actually be able to deal with data management at a much, just at the inception of the grant, rather than halfway through going, oh, wait a second, why, that's incentivized, really?
Just quickly on data management plans, EPFL does a lot of work around sustainability, and the team working on data management plan is now looking at how to include environmental impacts in that. So we've been working with them a bit. So hopefully there will be some exciting stuff coming out of that.
So Chris at the back.
I was going to ask about resilience. So you've got this data, brilliant, it's called EMDL. Suppose EMDL does down tomorrow. I mean, I hope it won't.
Well, we have 6 sites. There is a large amount of replication that happens with that data as well, which obviously comes with the footprint. I think what is probably more likely, or at least when we had when we were using the data center, so for those who don't know about our campus, we're very near to the Imperial War Museum based at Duxford, and there are a large amount of very old aircraft flying overhead. There have been aircraft that have landed in fields near to the airstrip. I think that was possibly more of an active kind of potential threat towards it, but the other way around it that we've been able to deal with is through multiple replicas of that data or so, and to ensure there's a certain degree of resiliency, and the data sets that we move to as well have that resiliency built into them as well. So as part of our tender process, as part of UKRI, we ensure that there are certain constraints around the resources that we move to and the areas that the data centers that we move to as well. But if it was a full burn down, I'm not sure how anyone would completely deal with that aspect without going through those same kinds of levels of checks and backups and everything else. We should say that actually in some cases we're not only just distributed in ourselves, but collaborations like the INSDC, which shares data between the US and Japan, just means that if our sites go down, then that data still remains available from other sources as well.
Any more on resiliency?
Just on the carbon footprint, the whole idea about carbon footprint shouldn't get in the way of duplicating data and backups, because in the long run it probably costs more to the environment to redo the analysis or regenerate the data than not losing it in the first place. So it's like a fine balance, and we don't want to go to the extreme of saying let's delete everything every year because who cares. And so yeah, it's about.
Yeah. So on the subject, has anybody got a question? If not, on the subject of trust, maybe maybe we can get more reuse of data that's already been calculated, already been processed, if somebody would trust that the data were good. So how do we engender that? How do we ensure that people do trust the data that we've been storing and making available?
I'm not going to answer, but I'm going to pass it to you, because that's one of the great things with EBI is that actually we trust the data a lot more.
I assume that's because we've been about for so long and because there's a history, this reputation that we've built up, but I mean, that would suggest that the only way to gain trust is to deposit with us, which I don't think is quite right, really. And I think Jazz's work on ensuring that there's good provenance of data creation, of how that data came to being, is the right way. So I would actually like to pass over to you.
Yeah, I think if you can see how that data was produced and maybe compare with how other data was produced as well. So maybe you know an example that works really well and then compare it. But I think also in our community, I guess the more that or if something is downloaded, quite often you can maybe trust it that way because loads of people have used it, but also publishing that data, you know that it has been reviewed, and so you can have a bit of trust because it has been published. Not always the case, but that's also another way to potentially trust that. But yeah, no, that's hard. Like you said, it might be incorrect, 2 years down the line and you never knew, but at least you can pinpoint where that data came from and who produced it, and I think that should be enough.
We've only got a few minutes left on the panel, but Jörg's got a question.
For me, data trust is not only the data I put a deposit at your place is space like that, is okay. It is also, it stays like that. You've got something like Bitrot, which is something you have to manage because it happens. And obviously, if you've got data in more or less one place, in inverted commas, because you duplicate and all of that, how can I be sure that not somebody comes along and says, okay, I don't like that sequence, I just replace it with mine. And the automatic replication kicks in, replicates it, and then you've got data which has been manipulated. That is the other aspect of trust.
Wow, that's a question now. That is. So first, when you talked about data integrity, that made me, or at least about the Bitrot problem, that made me think more about standardized file formatting and projects of file formats in the sequencing space. So originally, any vendor had their own in-house format, and there was SAM, then there was BAM, now CRAM, there are still other efforts as well, but normalization of data into standardized formats to ensure that that Bitrot doesn't actually happen, and then maintenance of the tool chain that surrounds those formats as well to ensure that, again, that data still remains accessible, because the other form of Bitrot is, so okay, I'm a Perl programmer at heart, I'm a Java programmer at heart, and then had to convert over into Perl, but ultimately Perl is now dead as far as anyone's concerned, and what would happen if the file format writer was only ever written in Perl, then that code, that data is now Bitrotted, so ensuring that the toolchain continues to move as and when with the trends of how computer science is progressing as well as one thing. The other aspect as well is, you mentioned about manipulation of data. That indicated something perhaps insidious in the process that was going on there, like a bad actor. And it ensures a certain amount of mistrust in the system, and I think that's where actually science fundamentally trusts the people involved in it. And if that trust goes, then kind of everything starts to fall down. But what we can do as well is those file formats can have integrity built into them as well, double checked. There can be ways, I know there's things I'm involved with in Global Alliance about checksumming content, generating ideas based on content itself, which therefore means, well, if you can digest the thing, then you can recreate that identifier as well. So there are ways and means of dealing with that you can do it in a way that doesn't undermine trust in the actual system overall as well.
So I see John had a question, but the alarm's gone off. It's time for...
Did we start before we finish?
I think what we can do is there's no coffee break next, but you could take that to a hallway discussion maybe. So I think it's time to thank the panel for their discussions on data management and trust.